A piece of wire 10 meters long is cut into two pieces. One piece is bent into a square and the other is bent into an equilateral triangle. How should the wire be cut so that the total area enclosed is A, a maximum, B, a minimum? So we have 10 meters of the wire, so we divided it into two parts, one part for the triangle and one part for the square. The first length would be x, and it would be the perimeter of the square. So one side of the square would be x over 4. The second part of the wire would be 10 minus x, and the side of the triangle would be 10 minus x over 3. The total area of the two shapes would be the area of the square plus the area of the triangle. The area of the square would be x over 4 all squared, plus the area of the triangle would be the base times height times half. So the height would be root 3 over 2 times the base. So the area of the triangle would be root 3 over 4 times 10 minus x over 3 all squared.
Now that we have the total area enclosed, in order to find x, we can take the derivative of both sides of the function, which is what we did here, and then results in this, which is 1/8 x minus the square root of 3 over 18 times 10 minus x, which is just simplified. And then we set dA over dx to 0, because we're trying to find the maximum and minimum. And in order to do that, we need to find the critical point. So x, as a result, is 40 times the square root of 3 over 9 plus 4 times the square root of 3, which is roughly about 4.35. Going back to the original equation of the area here, we know that the domain of x is greater than or equal to 0 and less than or equal to 10, since we know that the wire is 10 meters long. Therefore, it cannot exceed 10 meters and cannot be less than 0. Knowing that, we know that 0 and 10, therefore, must be the two endpoints. And in order to find the absolute max and absolute min, or not absolute, just the max area and the minimum area, we can put in 0, 10, and this number that we got for x above here, which is around 4.35, which is 40 square root of 3 over 9 plus 4 and the square root of 3, and find out what the area of each point results in. And here you can see that the area when the meter is when x equals 10, it is 4.81, and the area of the enclosed space when x equals 10 is 6.25, because that means the whole wire is used up to make the square. And here, the area of this number that we have found here, which is a 0, is 2.72. So therefore we know that the maximum occurs at 10 and the minimum occurs at 40 square root of 3 plus all over 9 plus 4 in the square root of 3, because this results in the smallest number and this results in the largest number. And we know that this is the greatest area that can occur since the wire is only 10 meters long, and we know that this is the minimum area that can occur.